Coding problems can seem overwhelming at first glance. Just take a look at this problem, Palindrome Number. This is a problem on LeetCode, and so in this problem it says, given an integer x, return true if x is a palindrome, and false otherwise. And this is overwhelming at first because we know how to determine if a number is a palindrome in our heads. You can just look at the order of the numbers of the digits in the number, and we can already determine if it's a palindrome or not. But how do we program this? We basically have to teach a computer how to do this. The thing that we're doing in our heads, we have to teach the computer to do that very thing. And this is counterintuitive, or this can be challenging at first because we do this naturally in our heads, but then now we have to lay it out explicitly. Coding problems can often feel like you're teaching somebody who has zero intuition whatsoever and all they have is logic, and then you have to appeal to that logic to teach them how to do something. And coding problems are also kind of annoying because these problems don't seem to be very practical. Like, why would you ever want to code a palindrome, or why would you ever want to code a function that can tell you if a number is a palindrome or not? So there's not much emotional investment into these coding problems. And so this is also a reason why this is overwhelming, or at least kind of annoying. In this video, I'm going to go through an easy LeetCode problem, this one in particular, and I'm going to show you a classic way of breaking down your coding problems into different steps so that you can solve your problems in a very systematic way. So my name's Henrik, and I'm here to help you learn the foundations of software development. So let's get started. But before we begin, I'd like to mention that I do have a free workshop for you. It's called my Capstone Project Workshop. And in that workshop, I go over 3 secrets to coding your own capstone project in just 3 months. Now, why did I create this workshop? The most common goal that I get from people who apply to my one-on-one programming mentorship program is to, quote, be more proficient at creating projects. You and I both know that learning how to code is more than just memorizing code syntax. It's about applying your coding skills to real-world projects that make you feel confident and capable. So if this sounds like you can download this workshop in the link in the description. And if you download it and watch it and pay attention to what it says, then you'll definitely build a good foundation to your software development journey. All right, so what is the first step to approaching a coding problem? First, you need to understand the problem. So a lot of times you can look at the title and then you can automatically assume what this problem is about, what it's trying to get you to code. And maybe you're in an interview and then they tell you to code this problem. And then you make some preliminary assumptions on what they're trying to get you to code, and then you actually make that problem to be harder than it actually is. And this actually happened to me many times. I would look at the title, or I would get a question in an interview, and then I would think that they're trying to get me to code something that they're actually not asking me to code. So it's really important to make sure you thoroughly understand what the problem is. So let's read it. Given an integer x, return true if x is a palindrome, and false otherwise. So for example, one misunderstanding is if you see this palindrome numbers, one thing you might think is you get an integer x and then you have to return the palindrome. But actually what you really need to do is you just need to return true if it is a palindrome. And that's a lot easier than returning the palindrome. Well, it depends on how you're coding this, but returning true or false is a very easy output for this function or this method. And another misconception you could have about this problem is it's a palindrome number, or maybe how do you know what the input is? Is it an integer x, or what if it's a decimal number? So if you're just looking at this title here and you're not really looking at what is the input is an integer, then you're going to start wondering, like, how would I check if a decimal number is a palindrome number? Or maybe you're thinking if the number is a string. So like you're starting to think, oh, what if it's a string? How would I go through the different characters of that string? But here you can see right away that it's an integer that's going to be the input. And this leads to the next step. So the next step, after you understand the problem, and maybe this goes hand in hand, but the next step is to identify what are the inputs of your function and the outputs of your function, or what are the inputs of your method and the outputs of your method. And so here you can see your input is an integer x, so you have to nail that down, and then your output is a Boolean, a true or a false. LeetCode is really good at this. It'll tell you exactly what it is. But if you're in an interview or if you're talking verbally with somebody, they might say, give me a function that will return if a number is a palindrome or not. But they don't specify what that number is. it really makes a difference on how you code it if you know that the input is an integer versus a string or like a decimal, like I mentioned earlier, or if it's a float or if it's a double. So you have to nail that down, what is the input. And LeetCode is really good at this. They'll actually give you the function here. So the function, and I'm going to code this in C. So the function here is palindrome, and then it already automatically determines the return type, which is bool, and then there's int x. So this is the most important thing that you're going to do for your coding problem, is determine the input and then the return type or the output. Also, in the context of doing your own code programming projects, and maybe you're not doing coding problems, say you have an idea for a feature, now you have to, one way you can approach that is you have to think, what are going to be the inputs and outputs of that feature? What are the necessary inputs or the necessary data that feature is going to need, and then what is that feature going to produce? So yeah, that's the second step that you need to think about. First, understand the problem or understand the feature that you're trying to implement, and then second, figure out those inputs and outputs. And the whole idea behind this is you want to make your program modular. You want to break down your program into different modular pieces, because if you break it down into modular pieces, that's good programming practice, and that also isolates your program into different pieces. So if you have a problem in the future, if you have a bug somewhere, you can isolate it to these individual blocks in your modular program. So in general, it's good to sort of compartmentalize your different features into their own little black boxes, or their own little boxes, or their own little functions, or their own files, so that you can separate out different functions and features from each other, and so that they're not dependent on each other. So if you break one feature, it's not going to break your whole program. It's just going to break that one section of your program. So this is why it's important to have a modular design, or have different blocks, or separate out different features in your program. All right, the third step is to come up with your strategy. So we need to look at this problem again. So given an integer x, return true. So one thing that I could think of right away is if it's a negative number, it's obviously not a palindrome. So if you look at example 2 right here, if x is negative 121, output false, because from left to right it reads this one. So therefore it is not a palindrome. So for negative numbers, we're just going to return false right away. So that's one strategy. Now I need to come up with a strategy for the positive numbers. So for the positive numbers, we need to come up with a way to isolate the different digits. So for example, this 121 here, we need to find a way, how can we get this first digit, or how can we get the next digit and the next digit? And so there are many ways you can do this. Maybe you could convert it to a string, and then look at this number, and then convert that into a number, and then that's how you can get that digit. Okay, so say we have 121 and we want to get that first digit. You can do a modulo 10 to get that first digit. And so if you do like modulo 122, you're going to get 2. So if we do modulo 10, we can always get that first digit. And the nice thing too is if you do divide. Now if you do divide, you're going to get 12.2. But if you're doing a integer type division, it's going to remove this decimal component because it's an integer. So it's only going to get the 12 here. So we can get this 2-digit with that modulo 10, and then we have this 12 integer that results from the division by 10, and then we can do modulo on this one to get the 2. So we do modulo 10, and then we get the 2 here. And then we do the division by 10, we get the 1 here. So now we need to come up with a way to go through the digits. And so we need some sort of loop to go through the digits. So in this loop, we're going to do the modulo 10, and then we're going to do the division by 10 to get the remaining digits from the division, and then the first digit or the last digit with the modulo. So we're going to need to do a loop. We need to do that how many times? We need to do it until we have no more digits left. So that's another thing we need to think about. Are we going to use a while loop or a for loop? Okay, so now step number 4 is to actually implement the strategy or implement the design. So we talked earlier about how we want to only handle the positive numbers. So we need to put an if statement here that if x is negative, then we return false right away. And then we'll just make the default to return true. If x is positive, we're just going to return true for now. Okay, let's go ahead and run this code and see if we pass case 2. So let's run this. Okay, so we passed case 1 because 121 is actually a palindrome, so our output was true because we just say true if it's positive. And then case 2, if it's negative, we return false. So we're passing this test case, but we're not passing this test case 3, because 10 is not a palindrome. So we said true. So we need to handle this test case here, this 10 here. All right, so now let's implement that while loop. So we're just going to have a while loop, and I don't know what the conditions are yet. We're just going to code a while loop here. And we said that we wanted to divide this, wanted to do modulo by 10 to get the first digit. So we can create a variable called digit. So go here in digit. So it's going to be a local variable, and then we're just going to get the first digit here, or the last digit, depending on your conventions, if this is the first digit or the last digit. The first digit that we're going to look at, and then the last digit of the number. So it depends on your coding convention. So we're going to get the digit here, and then we're going to do the division. X divided by 10, and then we're going to have some number here, and this number is going to be the number that we're currently examining. So maybe we'll call this number examine. So let's create another int examine. So examine is just going to have the rest of the digits. And then with this digit, we want to build our new number that we're going to compare with x. So x is the original number, and then we're going to be building a new integer that we're going to compare with x using this digit. So let's create another integer called reversed. And then we need to add this digit to reversed. So we're just going to do equals, and then reversed times 10 plus digit. So basically what this does is, say you have x is equal to 121. So in the first iteration of this while loop, let's expand this here. So if x is equal to 121, then digit is going to be 1. And then reversed is going to be 0. Let's initialize it to 0. I guess we can initialize all of them to 0 first. So reverse is going to be 0, 0 plus 1 is going to be reversed. So reverse is going to equal 1, and then examine is going to be equal to 12. And then we go through this while loop again. So in the second iteration, 12 modulo 10 is going to be 2. So 2 digit will be 2. So we want to make sure that this reverse is equal to 12 because we're adding this 2 digit. And so we want to make digit to be just add 2 to the number. So we need to move 1 over 1 place. So we have to do multiply by 10. So then it becomes 10 plus, or basically 1 times 10 to move over that 1 digit, and then we're just going to add 2. And so that's how we can make space for the 2. So we're slowly eating away from this number, like this going this direction, and then we're slowly building it up. So this one will be, so basically I think it'd be better if this was a 3, so you understand it better. So basically we want to reverse this x, so we're eating the 1 here, and then in the first iteration, reverse will be 1, and then the second iteration we want it to be 1, 2, and then the last iteration we want it to be 1, 2, 3. So this is why I chose this. So we're moving that digit over to the 10th spot, and then we're adding digits. So then this is going to equal 12. And then in the last iteration, we're going to do 1, 2, and then, oh yeah, I forgot to do examine. So examine is going to be, oh sorry, this is not 13, this is 32. So that examine is going to be 32 divided by 10. Oh sorry, what we need to do is we need to make this be examine, because we want to get the next digit over. So examine, we have to initialize examine to x. So examine is going to be 321. So examine will be this number. And then after the first iteration, examine is going to equal 32. And then the second iteration, then examine will be examine divided by 10. So then it's going to be 3. Oh yeah, and then this x should also be examine as well. So in the first iteration, examines will be 3, 2, 1. We divide by 10, or we do modulo 10 to get this 1. And then in the second iteration, examine will be 32. So when 32 comes up here, we do modulo 10, we're going to get the 2. And then 3, we do 3 modulo 10, and then we're going to get the 3. And then reverse is going to be equal to 12. And so what we want to do is we want to do 12. We want to move it over one place, and then we do 3. And then so that's going to be equal to 123. And then when we do examine again, examine will be 3 divided by 10 is going to be 0. Okay, so when examine is 0, then that's a good sign to exit the while loop. So what we do is we go here, and then we just say when examine is greater than 0. So as long as examine is greater than 0, we have more digits to parse through or to go through. So we're just going to keep doing this. And then by the time we're done, reverse is going to equal to 1, 2, 3. So we're just going to check if x is equal to the reversed. If it's true, we return true. And then else, return false. Okay, so this is our main algorithm that goes through and reverses the the number. Then we're going to check if x is equal to reverse, that means it's a palindrome. But if it's not, it's going to return false. So let's run this. And so there you go. So now we're returning false for this 10 case. So we're passing all of the 3 cases. Okay, so that was step 4, implement the strategy. Now step 5, which is the last step, is to test different edge cases. And so basically we want to just handle the normal case first, and all of these cases here that they have here. And these are the normal cases, but now we want to test some edge cases. So that means we have to come up with some other cases, or maybe test some other normal cases. But the main idea that I want to get at is you want to just worry about the normal case first and get that working. And then once that is working, then you start testing more edge cases. And what I mean by edge cases is the edge case is just an input that you don't expect. So maybe it's a really large number. So we have to come up with some test cases here. Or maybe what we can do is we can test some other normal cases, because 121 and negative 121 and 10 doesn't really test a lot of cases. I mean, these are not very exhaustive in terms of these test cases. Like I want to make sure we test 4-digit numbers or 5-digit numbers. So let's make sure we test those so we can add those test cases here. Okay, so let's do some other cases. So I'm going to do a 4-digit number and then a larger digit number. Okay, I think that's good. Maybe we do a 1-digit number. So now we're trying to test these are sort of like the edge cases, like cases that are not really normal. Okay, let's run. Okay, so we're passing all of the test cases. False. 5 is true. Yeah, that makes sense. This is false. And now let's do another case where it's a long number, but it is a palindrome. Okay, so we got this to be true. Okay, so it looks like our problem is solved. So we were able to do this. Actually, so if it's true, we return true. If it's false, we return false. So we can actually just replace this with this. So this is when we start cleaning up. And maybe that's the 7th or the 6th step, is to do some cleanup of your code. Maybe we remove these comments. So that's step 6, is clean up your code. Maybe comment it. Okay, let's run that. Okay, we're passing all of the test cases. All right, so we solved this easy palindrome number coding problem. I'm just going to recap the steps. So first is understand the problem. Make sure you read it thoroughly. Make sure you have a good understanding of it. Don't make some assumptions that don't need to be made. Otherwise, you'll make the problem harder than it has to be. Then second, understand the inputs and the outputs. So the input is integer, output is a Boolean. And so we have this definition here. Third step is to come up with your strategy. So how are you going to go about doing this? And you can look at the examples. This is actually part of how you can understand the problem and to begin with. Look at the examples. That will help you understand it right away. And if not, then if maybe you're in an interview, ask your interviewer for some examples. So then you have a better understanding. So third one is come up with your strategy. And then fourth, you're going to go ahead and implement the strategy. So we implemented our strategy. We just return false right away if it's a negative number, but if it's a positive number, then we use the modulo and the division here to actually create a reversed version of our integer. And then we compare it at the end and return whether it's true or false. And then we do some more test cases. So we look at all of our test cases. Of course, these three were very, very simple. So you want to really test thoroughly. Think of some edge cases, some cases that may not be a normal case, and then add those cases here. And the test cases here, add some test cases, and then keep running the program. And eventually you're going to run into some edge cases that you didn't handle correctly. And then you need to adjust your code accordingly. And then you can handle all of those edge cases. Like I mentioned earlier, I have a free workshop for you, my capstone project workshop. And in that workshop, I go over 3 secrets to coding your own capstone project in just 3 months. So if you want to become more proficient at creating your own projects, you want to move on from these tutorials and create your own projects, then be sure to check the link in the description and watch my coding workshop today. Alright, that's it for this week's video. I hope it really helped you out and give you some ideas on how to go about approaching your coding problems, your LeetCode coding problems, or your job interview coding problems, or any coding problem that you're encountering as you're building and developing your coding projects. So I hope it was really helpful for you, and if it was helpful for you, please like, share, and subscribe to the channel. And if you have any other questions, feel free to let me know in the comment section and I'll be sure to answer you there. And if you want me to do more LeetCode coding problems like this one, please let me know in the comment section, and I'll see you in the next one. Peace.